In this video, we're going to go through section 1.4, solving other types of equations. And what we mean by this is other types of equations that are not linear and are not quadratic. So, just going to go through a series of examples. The first one, we have x to the fourth equals 9x squared. Now, it's pretty tempting here to divide both sides by x squared. So let's do that and see why this doesn't lead to the correct answer. So what we get is x squared equals 9. So if we take the square root of both sides, we get x equals plus or minus 3. Now let's see what happens when we don't solve it in this way. So what I'm going to do is I'm going to bring everything to the same side. And what we can do is we can factor out x squared. We get x squared minus 9 equals 0. So now we have two different factors, and we can use the zero product property to set each of these factors equal to 0. So here we get x equals plus or minus 3. Here, when we take the square root of both sides, we get x equals 0. So this is really what the solution set is. Now if we go back to what happened when we divided by x squared, well, by dividing by x squared, we are removing important information, and that information would lead us to include a value of 0 as a solution. So anytime we divide by the variable, similarly, anytime we multiply by the variable, we need to be careful about that. So we don't ever want to divide by the variable, and we'll see what happens when we multiply by the variable in this next example. We have let's see, x equals square root 6x minus x cubed. Okay, so what we're going to do here is we're going to square both sides to remove the radical. Now on the left-hand side, what we're really doing is we're multiplying x by x. So we get x squared. On the right-hand side, squaring a radical just gives us the radicand. So what we're going to do next is set this equal to 0. So I'm going to add x cubed to both sides. We'll have x squared minus 6, like this. And then let's factor out an x. And what we see is that we get, I forgot to put an x here. What we get is a quadratic multiplied by x. So we have the zero product property. We can say x here is equal to 0, and then x squared plus x minus 6 equal to 0. Well, this is a quadratic that can be factored. We're going to say x plus 3, x minus 2. So x is equal to negative 3, x is equal to 2, and x is equal to 0. Now, because we squared both sides up in the first step, we need to be careful, because what happens when we square both sides in this instance is we're actually multiplying the left side by x. We're introducing an extra factor of x into this problem. So whenever we do something like this, we need to check our solutions. So let's check each of these solutions. So when x is equal to 0, does that work? So we get 0 equals square root 6 times 0 minus 0 cubed. We get 0 equals square root 0, 0 equals 0. So that works. When x is equal to negative 3, what happens? We have negative 3 equal to 6 times negative 3 minus negative 3 cubed. We get negative 18. Negative 3 cubed is negative 27, and then minus a negative 27 is plus 27. We get negative 3 equals square root of 9. Well, negative 3, we take the square root of 9, we get 3. So that actually does not work. So that x equals 3 is not a solution. And then let's check x equals 2. We get 2 equals square root 6 times 2 minus 2 cubed. 2 is equal to square root of 12 minus 8. 2 equals square root of 4, so 2 is equal to 2, and that's good. So our solutions here are just going to be x equals 0, x equals 2. And again, anytime we introduce an extra x as a factor, we need to double check our answers. Let's check out an equation where we have fractions, and these fractions have x in the denominator. So we saw one of these in section 1.3, or a question that was similar. We want to multiply by the least common denominator. So the least common denominator here is going to be one copy of each distinct denominator. So the least common denominator is going to be 6 times 1 plus x times x. So we multiply that out, we get, let's see, x plus x squared, so 6x plus x squared. However, it may just, for this problem, it's probably just going to be easiest to leave it in the factored form. So what we want to do is each term we want to multiply by that least common denominator. So 6 times 1 plus x times x. You don't necessarily need to write it out for each term like I am, but you do need to multiply each of these by the least common denominator. So 6, 1 plus x, and running out of room. Okay, so what's going on here? In this first fraction, well, the 6 and the 6 are going to cancel, so what we have is 1 times x, or 1 plus x times x. In the second fraction, the 1 plus x and the 1 plus x are going to cancel, so we're going to have 1 times 6 times x equals 2, and then x and x cancel, so we have 1 times 6, 1 plus x. So the whole reason to multiply by the least common denominator is to get rid of all of our fractions, and we've done that. Now we just have to solve this equation. So let's simplify everything first. On the left-hand side, well, we can just kind of ignore the 1. We're going to have x plus x squared plus 6x is equal to 6 plus 6x here. So on the left, we'll have x squared plus 7x is equal to 6 plus 6x. This is a quadratic equation because we have x squared, so let's set this equal to 0. Minus 6x, so plus x minus 6. And this is going to factor, so x plus 3, x minus 2 equals 0. X plus 3 equals 0, so x is equal to negative 3. And then we have x is equal to 2. Now we need to check these because what happened was we multiplied by the variable. Because we did that, our solutions that we found may not actually work. They may be what's called erroneous solutions. So let's check x equals negative 3 first. We're going to have 1 over 6 plus 1 over 1 plus negative 3. Does that equal 1 over negative 3? Well, 1 over 6 plus 1 over negative 2. Okay, well, let's get everything in turn with a denominator of positive 6. So 1 over 6, I need to multiply the top and bottom of the second fraction by negative 3. So we'll get negative 3 over 6. And then on the right-hand side, we need to multiply by negative 2. So we get negative 2 over 6. And we get the left-hand side equal to the right-hand side. So that's good. So x does, in fact, equal negative 3. Then let's see if I can fit this here. Does x equal 2? Well, we have 1 over 6 plus 1 over 1 plus 2 is going to be 1 over 3 equal to 1 over 2. Is that true? Well, let's get everything in with a denominator of 6, 1 over 6 plus multiply here by 2 over 2, so 2 over 6 is equal to multiply here by 3 over 3, 3 over 6, and yes, you get the left side equal to the right side. So what that means is both of these values are in fact correct solutions. So in these next few problems, we have equations where the exponent is not an integer. Like in this one we have 3/2, and I think this needs to equal 24 here. Okay, so what we do is we isolate the expression that has the 3/2 as its exponent. So we're going to get this part all by itself first. So add 30 and then divide by 2. We're going to get 2x minus 1 to the 3/2. 24 plus 30 is 54. 54 divided by 2 is going to be 27. All right, so what we do at this point is we need to eliminate this exponent. So what we do is we raise both sides to the 2/3. So on the left-hand side, 3/2 times 2/3, well, that's just 1. So on the left, we get 2x minus 1 raised to the first power. On the right-hand side, when we have a fraction exponent, the top tells us what we raise the base to. So this could be read as 27 to the second power. And then the 3 tells us what root we take. So we can go in either order. We can either square first and then take the cube root, or take the cube root and then square. I'm going to cube root first. So 27, the cube root of 27, we can write it like this, 27 cube root, and then that is getting squared. So 27 cube root of that is 3, so 3 squared is equal to 9. So the right hand side over here is going to be equal to 9. And then just solve for x. So 2x is equal to 10, x is equal to 5. And it's not necessary to check this answer because when we squared, or rather when we raised both sides to the 2/3, we didn't actually multiply anything by the variable again. It was just, we were just working with constants on the right hand side, and on the left hand side we didn't actually do any multiplying. The exponents just canceled. So as long as our algebra is correct, 5 should be a correct answer here. All right, moving on, 3x minus 1 raised to the 2/3 plus 5 equals 9. So this is similar to the last one. Let's subtract 5 from both sides first. And then we're going to raise everything to the 3/2 power. So on the left, the exponents cancel. We get 3x minus 1. On the right, we're going to take the square root of 4, which is 2, then 2 to the 3rd power. 2 times 2 times 2 is 8. We could also do 4 to the 3rd, which is 4 times 4 times 4, which is 64. Square root of 64 is also 8. So we get 3x is equal to 9, x is equal to 3 here. Now this last one is a little bit more challenging. We would say that this equation, x to the 2/3 minus 5x to the 1/3 plus 6 is equal to 0. Now what we're going to do is, one thing to notice is that we can kind of solve this as though it's a quadratic after we make a substitution. So what we're going to do is we're going to say let y equal x to the 1/3. So that means this we can substitute as 1/3. And then what we need to notice is that x to the 2/3 is just x to the 1/3 squared. So y squared is equal to x to the 2/3 like this. So let's make this substitution. Y squared minus 5y plus 6 is equal to 0. And now this looks like a regular old quadratic equation. So factor this to solve. Y minus 3, y minus 2. We're going to get y minus 2 equals 0, y minus 3 equals 0, y equals 2, y equals 3. Now this is great, but we don't actually want to solve for y. We want to solve for x. So what we're going to do is, let's substitute this back up here, which with what y is actually equal to. So 2 is equal to x to the 1/3. 3 is equal to x to the 1/3. So raise both sides to the third power, or 3/1. And that'll eliminate the 1/3. So on the left side, we're going to have 2 to the third, which is 8. That'll be x. Those cancel. And then here we're going to have 3 to the third, which is 27. And that is equal to x. So there are our solutions.